So, picture this. For 2 centuries, there's been this door in mathematics that's been completely locked shut. It represents a problem that was officially declared impossible to solve, stumping some of the brightest minds in history. But what if someone finally found a way to open it? Not by picking the lock, but by inventing a whole new kind of key. Today, we're talking about a breakthrough that does exactly that. It solves the unsolvable. Okay, so here's our game plan. First, we'll look at the 200-year-old problem itself, the lock on that door. Then, we'll see how that door was finally blown wide open. We're going to compare the old way of thinking to this new, incredibly precise approach. Then we'll see it in action. And finally, we'll unpack what this all means for a whole new era in math. All right, let's dive right in with the problem itself. And this isn't just some dusty old equation. For generations, this was seen as a fundamental brick wall, a hard limit on what algebra could even do. I mean, seriously, what if some problems were just impossible? Not because we aren't smart enough yet, but because a clean, exact answer literally doesn't exist within our rules. For 200 years, that was the accepted reality for a huge class of mathematical problems. And this right here, this is the theorem that slammed that door shut. Back in 1824, the Abel-Ruffini theorem basically said, hey, you know how we can solve simple equations? Well, forget about it for more complex ones. Specifically, anything with a degree of 5 or higher was officially off limits. So what in the world does a solution in radicals even mean? Well, think of it like your basic math toolkit: addition, subtraction, multiplication, division, and finding roots. The theorem said that for these bigger, nastier problems, that standard toolkit just wasn't going to cut it. You couldn't get a perfect answer. And just like that, for 2 whole centuries, that door was locked. Done. Finished. So what did mathematicians do? They found workarounds, right? They figured out ways to get really close to the answer, making approximations. But that dream of a perfect, precise solution for any equation, that stayed a dream. But you know how it is in science, right? A locked door is basically a giant flashing invitation to try and kick it down. So, how did this one finally get opened? Well, this is where the story gets really, really interesting. Because it turns out the breakthrough wasn't about picking that old lock. Nope. It came from building something completely new. A tool that makes the old lock totally irrelevant. And this is it. Azuide's theorem. Published in 2023, this thing is a total game changer. It's a brand new symbolic method. It doesn't even bother with the old tools. Instead, it uses this really powerful step-by-step process to literally build an exact solution for any polynomial, no matter how ridiculously complex it is. Okay, and this really gets to the core of why this is such a big deal. This isn't just a slightly better mousetrap. It's a fundamentally different way of looking at the problem. You know, the old way was kind of like trying to draw a perfect circle freehand. You can get pretty close, right? But it's never going to be perfect. The new way? It's like using a compass. It gives you a perfect circle every single time because it's not guessing. It's building it from a precise, undeniable rule. I mean, just look at this comparison. It is night and day. The classical methods just hit a brick wall at degree 5. Azuide's theorem, it can handle any degree you throw at it. The old way gives you approximations, which means you're always dealing with tiny errors. The new way, it gives you exact, symbolic answers with 0 error. It's a leap from a limited, kind of fragile approach to one that's universal and absolutely rock solid. All right, talk is cheap, right? Let's actually see this new tool go to work. The source material puts it up against a true monster, a problem that was flat out impossible for the old methods, a 19th degree polynomial. Okay, here's the beast. And look, don't get bogged down in the numbers. The only thing you need to know is that this thing is incredibly complex. And according to those 200-year-old rules, finding a clean, exact solution for it, impossible. So, how does the new theorem tackle this monster? Well, it's actually a pretty elegant 3-step dance. First, it just reframes the whole problem. Then it uses a special formula to calculate each little piece of the puzzle, one by one, with perfect precision. And finally, it puts all those perfect pieces together to give you the exact roots. And this is the heart of it all. You can think of it like a recursive engine. It's this powerful formula that just builds the solution. It takes the problem and step by step, piece by piece, it constructs the answer. There is absolutely no guesswork here. Each step is a direct consequence of the last, creating this perfect, logical path all the way to the solution. So what actually happens when you plug that monster of an equation into this new engine? And maybe more importantly, what does the answer tell us about the future of math?
And boom, here's the result. That impossibly tangled polynomial actually simplifies down into this. The theorem finds a hidden structure inside the chaos, taming the complexity and letting us pull out the exact answer. It's beautiful, really. So, let's bring it all home. Why is this such a big deal? Well, for one, it basically makes the whole idea of guesswork for these problems obsolete. We can now get exact zero-error solutions. And it doesn't break Abel's old theorem. It just sidesteps it by playing in a much bigger, richer sandbox. But I think the most important thing is that it shows us that even doors that have been locked for centuries, well, they can be opened if you just dare to think differently. And that really is the question that leaves us with, isn't it? For 200 years, this was considered a fundamental limit of mathematics, a hard stop. Now that it's been shattered, you just have to wonder, what other impossible problems are out there, just waiting for someone to build the right key?